Hello everyone, welcome back to this exercise series for chapter 6 of our BUS 325 investment course. In this video we're going to be looking at problem number 8, but before we do that we do have a note in the textbook for all of the problems between 8 and 12 that says a pension fund manager is considering 3 mutual funds. The first is a stock fund. The second is a long-term government and corporate bond fund. And the third is a treasury bill. Money market fund that yields a sure rate of 5.5%. The probability distributions for the risky funds are given below. Here we have the expected return on the stock fund is 15% and its standard deviation is 32%. Whereas for the expected return on the bond fund is 9% and the standard deviation is 23%. One more thing to note is that the correlation between the fund returns is 0.15. Okay? Then the question says, tabulate and draw the investment opportunity set of the 2 risky funds. Use investment proportions for the stock fund of 0% to 100% in increments of 20%. What expected return and standard deviation does your graph show for the minimum variance portfolio? Okay, now there are 2 ways to do this. One way is to use the graph and the other way is through the minimum variance calculation that we've learned in the lecture. We are going to do the calculation. We're not going to worry much about the drawing, so we're going to ignore this part here and this proportion. Okay, first let's write down our data that is given in the question. So these will represent the inputs or the parameters of the opportunity set, and those include the expected return on the stock fund. We'll denote it as expected return S, and this is 15%. Okay, and the expected return on the bond fund, we'll denote it by expected return B, is 9%. Okay, we also have the standard deviation of the stock fund, which is 32%, and the standard deviation of the bond fund, which is 23%. Okay, we also know the correlation coefficient, right, which we'll denote it as P equals 0.15, right? And the question also gave us the risk-free rate right here to be 5.5%. So R F equals 5.5%. Okay, now that we know these inputs, we can go ahead and calculate or generate what is called the covariance matrix. Okay, the covariance matrix is going to help us have all the inputs that we're going to use in our formula. It's going to make the substitution in our formula a lot easier. I'll show you how. Okay, the covariance matrix is going to look like this. You're going to have bonds and stocks, and here we're also going to have bonds and stocks. Okay, now for these places here, we're just going to take the square root of the standard deviation for the corresponding assets. So for the bonds, we have a standard deviation of 23%, right? So we'll go to our calculator. 23% squared, or to the power of 2, that will give us 529. Okay. For the stocks, we have a standard deviation of 32. So in the calculator, we'll say 32 to the power of 2. That will give us 1024. Okay. Whereas here, for the intersections between bonds and stocks, and here as well, right, we're going to use another calculation. We know that the covariance, okay, for two funds is equal to the correlation coefficient multiplied by the standard deviation of the first fund multiplied by the standard deviation of the bond fund. Okay, so that's covariance of two funds, one of them a bond fund and the other is a stock fund. Okay, so just keep that in mind. So for this here, this is how we going to calculate in our calculators. We're going to say 0.15 multiplied by 32% multiplied by 23%. Okay, so let's do that. 0.15 multiplied by 32 multiplied by 23. Okay, and that's going to give us 110.40. Okay, and the same result also is going to be here, because multiplication works both ways. So if we multiply the correlation coefficient by 32% and then 23%, it's going to give us the same result as if we have done the opposite. So 0.15 multiplied by 23% and then multiplied by 32%. Okay, hence why these two will always be the same. All right, so this is our covariance matrix. Now let's go to our formula and see how does the correlation or the covariance matrix helps us with the calculation. So the formula is the minimum variance, or the weight of the minimum variance portfolio of the stock fund is going to equal to standard deviation of the bond squared minus covariance of the two funds, okay, over standard deviation of the stock fund squared plus the standard deviation of the bond fund squared minus 2 covariance of the two funds. Remember how I told you in class that I know the formula might look scary, but once you see it in the exercise, it should make more sense. It should be easier to calculate with. Okay, so notice that all of the requirements in the formula already we've figured out here in the covariance matrix. So now we can use these as inputs in the formula to substitute. For example, the sigma, or the standard deviation of the bond fund squared, which is this number. So we'll just substitute that. The covariance is here. So we'll just substitute here. And the standard deviation of the stock fund squared is also already calculated here. So we'll take this and substitute in the formula. And again, standard deviation of the bond fund squared will substitute here. And then we also have the covariance, as we have mentioned, but which is this, sorry, but here we're going to multiply it by 2. All right, so let's do that. So the weight of the stock fund in the minimum variance portfolio is going to equal to 529 minus 110.4 over 1024. 24 plus 529 minus 2 multiplied by 110.4. Okay. Now back to our calculators. In the denominator, 529 minus 110.4. That would be 418.60. And then the denominator, 1024 plus 529 minus, open a bracket, 2 by 110.4, close the bracket, and we get 1332.20. Okay. Now we simplify our fraction. 418.6 divided by 1332.2, and we get 0.3142. Okay, which we then transform into a percentage, because this represents the allocation or the asset allocation for the stock fund in our minimum variance portfolio. Okay, so that would be 31.42%. This proportion of our portfolio is going to be allocated to stocks. Okay, now for the allocation to the bond fund, we're going to follow this simple formula. Since we know this already, okay, now the allocation to the bond fund is only going to be 1, which represents the 100%, minus the answer in the previous step. So that would be 1 minus the weight of the stock fund and the minimum variance portfolio, and that would be 1 minus 0.3142. Okay, which is going to equal to 1 minus 0.3142. That would be 0.6858, which equals to 68.58%. Okay, so now the minimum variance portfolio is going to be allocated this way. You don't have to do this graph, but I'm just trying to help you understand. We're going to have about 31% of the portfolio allocated to stocks. That's 31.42%, and the remaining 68.58% is going to be allocated to the bond fund. Okay. Now we can calculate the expected return on the mean variance or the minimum variance portfolio based on these allocation weights. So now we know the weight that would be allocated to the stocks and the weight that would be allocated to the bond fund, and we also know the expected return on each of those. Okay, so here we just add one extra page. We're going to say the expected return on the minimum variance portfolio is going to equal the weight of the stock fund multiplied by the expected return on the stock plus the weight on the bond fund multiplied by the expected return on the bond fund. Okay, and that would equal 0.3142, which is this, multiplied by the expected return on the stock fund, which is 15%, right here. I'll close this in a bracket, plus 0.6858 multiplied by the expected return on the bond fund, which is 9%. Now bear in mind, you can use decimal format here or percentage format. Just know that if you use percentage, you don't have to multiply by 100 at the end. You will get your answer ready in a percentage format. But if you use decimal format instead, once you find the final answer, you need to multiply it by 100. Okay, I hope this part is clear. So let's run the numbers. 0.3142 multiplied by 15. That gives me 4.71 plus 0.6858 multiplied by 9%. That gives us 6.17. Okay. We add those two together. We get 10.88. Okay, notice how I got my answer in a percentage format right away because I did not transform these into decimal formats. All right, now we know the expected return on the minimum variance portfolio. We also want to know what would be the standard deviation on the portfolio as a whole. We know the standard deviation on the stock fund. We know the standard deviation on the bond fund. We now know the covariance, so we can use the following formula to figure out the standard deviation on the minimum variance portfolio is going to equal the weight of the stock fund squared multiplied by the standard deviation of the stock fund squared plus the weight of the bond fund squared multiplied by the standard deviation of the bond fund squared plus 2 weight of the stock fund multiplied by the weight of the bond fund multiplied by the covariance of the two funds. Okay, and all of this will be to the power of 1/2. Okay, so basically we'll take the square root of this. All right, now let's substitute. The weight of the stock fund, as we have seen already, is here, right? So 0.3142 multiplied by the standard deviation of the stock fund squared, which we already know because we calculated here, so 1024, plus the weight of the bond fund. I'll just copy it from here, 0.6858 squared multiplied by 529 I'm not gonna square it again because we already done that, so I'm just taking the squared number from our covariance matrix right away. All right, plus 2 multiplied by 0.3142. I think I'm gonna have to, I'm gonna need more space, so I'm just going to shift this a little bit to the left, and hopefully we'll have enough room, multiplied by the weight of the bond fund, which is 0.6858, multiplied by the covariance. Also, we calculated that in our matrix, so 110.4, all to the power of 1/2. Okay, now all you need to do is just run these numbers in your calculator one by one. Be careful with rounding and things like that. I'll do that right now. And I would also recommend that you do it step by step. So for example, just do the first bracket first, simplify it, write down the answer here, then plus, and then simplify this, write down the answer here, and so on. Okay, this will make your life easier and helps you avoid making mistakes. 0.3142 to the power of 2 multiplied by 1024, and I got 101.09 plus 0.6858 to the power of 2 multiplied by 529, and I got 248.8 for this one, plus 2 multiplied by 0.3142 multiplied by 0.6858 multiplied by 110.4, and for this one I got 47.58. Of course, don't forget all of this is in a bracket and raised to the power of 1/2. Okay, so I'll simplify this further now. 101.09 plus 248.8 plus 47.58 we'll get 397.47. I'll take the square root of that, and that will be 19.94%. Okay, which is what's required. I'm just gonna erase this here and show again that this is the standard deviation of the minimum variance portfolio. Okay, this is how you solve a similar question. Again, remember, we are not solving the whole question. I have adjusted it because I don't really require you to do any graphs. If you would do the graph, it would, just like we showed in the class, it would look something like this. Let me show you real quick. Okay. You'll have different combinations of the portfolio, something along these lines, and the minimum variance portfolio would probably be somewhere around here. Okay, and it would have an expected return, just like we calculated, of 10.88%, and it will have a standard deviation of 19.94%. So if I plot this here, this is the standard deviation, and this is the expected return. So this would be 19.94%, and this here would be 10.88%. Okay, but I don't really ask you to graph. It's worth knowing to relate to what we've covered in the lecture, but for this question, we're going to skip the graph. We just need to do this mathematically and just find the expected return on the portfolio. First of all, you're gonna need to find the weights for each component of the fund. So we found that the weight of the stock fund in our minimum variance portfolio to be 31.42% and the bond component to be 68.58%. And based on those weights, once we know the weights, we already know the standard deviation and the expected return of each of these components. We can figure out the expected return on the whole portfolio and the standard deviation of the portfolio. All right. I hope you found this video useful. This is how we solve a similar question to question number 8. If you have any questions, please feel free to drop them down in the comments. And until I see you in the next exercise, take care.